You need to know the hazards of the chemicals you work with and around every day. Chemical burns, respiratory problems, fires, and explosions can result when we don't know and understand the health hazards and physical hazards associated with the chemicals we work with. That's why the Occupational Safety and Health Administration, or OSHA, produced the Hazard Communication Standard known as HAZCOM. The Hazard Communication Standard is now enhanced with the globally harmonized system of classification and labeling of chemicals, better known as the GHS. GHS provides a more standardized way of communicating chemical hazards on labels and SDSs, not just in the United States, but throughout the world. This standardization will reduce trade barriers between countries, enhance understanding of hazards, reduce confusion in the workplace, help prevent injuries and illnesses, and ultimately save lives. The HAZCOM standard, enhanced with GHS, not only gives workers the right to know the chemicals and hazards they face, but the right to understand them and how to protect themselves from danger. In this program, we'll cover the 6 classes of hazards, the components of labels with pictograms, the 16 sections of safety data sheets, and how all this information will be communicated to you by your employer, including the required Employer Hazard Communication Program. Manufacturers and importers must determine the hazards of chemicals they produce or import through a detailed hazard classification system identified in the HAZCOM standard. To familiarize you with this system, let's briefly cover each of the 6 classes of hazards. A physical hazard exists from chemicals that pose one of these effects: explosive, flammable, oxidizer, self-reactive, pyrophoric, self-heating, organic peroxide, corrosive to metal, gas under pressure, or emits flammable gas when in contact with water. Examples of physical hazards include heat, cold, noise, ionizing and ultraviolet radiation, and vibration. A health hazard is a chemical that poses acute toxicity, skin corrosion or irritation, serious eye damage or eye irritation, respiratory or skin sensitization, germ cell mutagenicity, carcinogenicity, reproductive toxicity, specific target organ toxicity, or aspiration hazard. An example of a health hazard is corrosive sulfuric acid found in battery acid. Another example of a health hazard is the carcinogen benzene. A simple asphyxiant hazard is a substance or mixture that displaces oxygen in the atmosphere, causing those exposed to be deprived of oxygen. Those exposed to a simple asphyxiant hazard can become unconscious and even die. An example of a simple asphyxiant hazard is nitrogen in a confined space. Combustible dust is a finely divided solid material that can catch fire or explode if ignited in air. Examples include metal dust, such as aluminum and magnesium, wood dust, coal and other carbon dusts, plastic dust and additives, biosolids, other organic dust such as sugar, flour, paper, soap, and dried blood, and certain textile materials. A pyrophoric hazard is a gas that will spontaneously ignite in air at or below 130 degrees Fahrenheit. Silane is an example of a pyrophoric gas. Silane is used as a water repellent and in solar panel manufacturing. Finally, there are hazards that are HNOC, hazards not otherwise classified. A hazard that falls into this class is an adverse physical or health effect identified in the classification process that does not meet the criteria of other health or physical hazards, but either falls below the cutoff value or concentration limit of the hazard class or is under a GHS hazard category that has not been adopted by OSHA. Chemical manufacturers and importers are required to label containers to communicate what the chemical is, its hazards, and how to protect you. Specifically, labels must have a product identifier, a signal word, hazard statements, pictograms, precautionary statements, and the name, address, and telephone number of the manufacturer, importer, or other responsible party. All of this information must be located together on the label. The product identifier simply tells what is in the container or package. The name should match the name used on the safety data sheet. It should also note the chemical identity, including all hazardous ingredients. A signal word simply alerts the reader quickly to the severity of the chemical's hazard. For example, danger and warning are common examples of signal words. A hazard statement is a short phrase that describes the nature of the hazards of the product. For example, you might see highly flammable liquid and vapor may cause liver and kidney damage. Precautionary statements briefly and concisely explain recommended measures for safe handling, storage, and disposal. Examples include keep container tightly closed, store in cool, well-ventilated place that is locked, do not breathe vapors, wear protective gloves, do not eat, drink, or smoke when using this product. It may also indicate how to handle an incident involving the product. Pictograms, which are drawings or symbols to represent a specific message, are required on every label to quickly alert workers to what they may be exposed. There are 9 pictograms from which chemical manufacturers and importers can choose that match the hazards of each product. Each pictogram has a symbol on a white background with a red border and represents a specific hazard. The health hazard pictogram shows the outline of a person with a star in the center and applies to chemicals with one of these characteristics: carcinogen, mutagenicity, reproductive toxicity, respiratory sensitizer, target organ toxicity, or aspiration toxicity. The flame pictogram shows the symbol of fire in the center and applies to chemicals with one of these characteristics: flammable, pyrophoric, self-heating, emits flammable gas, self-reactive, or organic peroxide. The exclamation mark pictogram shows an exclamation mark in the center and applies to chemicals with one of these characteristics: irritant, skin sensitizer, acute toxicity, narcotic effects, respiratory tract irritant, or hazardous to the ozone layer. The gas cylinder pictogram shows a gas tank in the center and applies to chemicals that are gases under pressure. The corrosion pictogram shows 2 test tubes, one dripping liquid and eating into a solid surface, and the other dripping liquid and eating into a human hand. This pictogram applies to chemicals that may corrode or burn the skin, cause eye damage, or are corrosive to metals. The exploding bomb pictogram shows a ball in the center that is broken with lines bursting out. This pictogram applies to chemicals that are explosive, self-reactive, or are organic peroxides. The flame over circle pictogram literally shows a flame emitting above a circle and applies to chemicals that are oxidizers. The environment pictogram, which is not mandatory, shows a bare tree and a body of water with a fish upside down. This pictogram applies to chemicals having aquatic toxicity. The skull and crossbones pictogram literally shows a skull and crossbones image in the center and applies to chemicals having acute toxicity, being fatal or just toxic. Become familiar with these 9 pictograms so you can easily recognize the corresponding hazards of the chemicals you work with. We just covered responsibilities of the chemical manufacturer or distributor for labeling hazardous chemical containers. Next, we will discuss the labeling requirements at the workplace. Since chemical container labels contain important information, the labels on shipped containers that arrive in the workplace need to be kept in good condition all the time. If you notice a damaged label, report it to your supervisor to have it corrected immediately. Your workplace may use signs, placards, process sheets, batch tickets, operating procedures, or other such written materials instead of affixing labels to individual stationary process containers, as long as this method conveys the same information as the chemical manufacturer's container label. Safety data sheets, or SDSs, which were formerly known as Material Safety Data Sheets, or MSDSs, are another way to communicate the hazards of chemical products. Chemical manufacturers, distributors, or importers are required to provide them. Employers are required to make them readily available, but you are responsible for reading them and applying the recommended safe work practices to protect yourself. Let's familiarize you with SDSs by briefly covering each of the 16 sections used in the uniform format that is required. Section 1 is called Identification and includes the product identifier, the manufacturer or distributor name, the address, telephone number, emergency telephone number, recommended use, and restrictions on use. Section 2 describes hazards identification and covers all hazards of the chemical and the required label elements. Section 3, called Composition Information on Ingredients, provides information on chemical ingredients, including trade secret claims. Section 4 describes first aid measures, separated out by routes of exposure and identifying the most important symptoms and effects. This section also explains when immediate medical attention and special treatment are needed. Section 5, called Firefighting Measures, outlines extinguishing techniques, equipment, and any chemical hazards from fire. Section 6 describes accidental release measures, which describes emergency procedures, protective equipment, and how to contain and clean up when that product is spilled, released, or otherwise involved. Section 7, called Handling and Storage, identifies precautions for safely handling and storing the chemical product, including any incompatibilities. Section 8 describes exposure controls personal protection and indicates OSHA's permissible exposure limit, or PEL, ACGIH threshold limit values, or TLVs, recommended engineering controls, and personal protective equipment, or PPE. Section 9, called Physical and Chemical Properties, lists the chemical's characteristics such as appearance, odor, melting or freezing points, flash point, evaporation rate, flammability, and solubility, just to name a few. Section 10 describes stability and reactivity and indicates the product's stability, possibility of hazardous reactions, conditions to avoid, incompatible materials, and hazardous decomposition products. Section 11, called Toxicological Information, describes the likely routes of exposure, symptoms of exposure, numerical measures of toxicity, and whether or not the product is listed in the National Toxicology Program (NTP) Report on Carcinogens, or has been found to be a potential carcinogen by OSHA or in the International Agency for Research on Cancer (IARC) monographs. Sections 12 through 15 describe ecological information, disposal considerations, transport information, and regulatory information. However, environmental sections 12 and 13 are not regulated or enforced by OSHA, therefore may not appear on all SDS. Section 16, called Other Information, identifies the date of preparation or last revision of the SDS. Read and be familiar with the SDSs for the chemical products you work with. Knowing and understanding this 16-section format will help you respond quickly should you need to refer to an SDS during an emergency. Your employer will maintain copies of all SDSs for chemical products you work with. They will be made readily accessible for you during each work shift in your work area. As long as there are no barriers that would prevent you from accessing SDSs, electronic access to SDSs is allowed. In addition to SDSs, a list of chemicals used in your work area will be maintained and available to you for your reference. To help you know and understand the hazards of the chemicals you work with, your employer must communicate them to you. Elements covered in this written program include how to obtain and access SDSs and the list of hazardous chemicals, the hazards of non-routine tasks, such as entering a confined space with chemical and physical hazards, the hazards of chemical products found in unlabeled pipes, and the workplace labeling system, including the system for incoming shipped chemicals. Your employer's written chemical hazard communication program will be made available to you for review upon request. In fact, your employer will let you know where to find the written Chemical Hazard Communication Program, the list of hazardous chemicals, and all safety data sheets for the chemicals you work with. Your employer will also inform you of how the presence or release of hazardous chemicals in your work area will be detected. To know and understand the hazards of the chemicals you work with is vital to your safety and even your survival. The requirements of the Chemical Hazard Communication Program enhanced with GHS will help you achieve understanding. In this program, we explained the 6 classes of hazards, what you can expect to find on labels and SDSs, and how your employer will communicate chemical hazards, including the implementation of a written Chemical Hazard Communication Program. Become familiar with the labels and SDSs of the chemicals you work with and around. To know and understand is one more step to working productively and safely.